Hello, hello, hello. Right, and my mic wasn't connected. Isn't that funny? Well, anyways, we should be live, and I'm just gonna get the URL out to some people. Just a second. And I've got someone asking me if I'm looking for an internship. Yeah, I definitely am, so I'm gonna reply that. And all right, so that's that. And right, so I'm all amped up for today. I've been doing a lot of repetitive lead code and I want to learn some new, I feel like learning some new algorithms today. I mean, how long can I just stick to fucking queues and stacks and arrays? Wait, am I gonna get an internship called live on YouTube? It's gonna be awesome, isn't it? Right. Anyways, data structures and algorithms. I was thinking of learning a new algorithm, but we'll see. Okay, let's just take a look at what questions we have and then we can see if it's out of my pocket. We're just gonna learn some new fucking algorithms, and if it's not, then yeah, we get to solve lead code questions. Why am I so fucking excited about it? This is the worst part about being a developer. Right. Where's, yeah, there it is. Right. Uh-huh. So stacks and queues, learning prefix, infix, yada, postfix to infix. Let's do that. I kind of remember the sort of patterns we were practicing yesterday. So this should be pretty nice. Postfix to infix. I've already looked at this question. That's weird. Postfix to infix, and I've probably solved it already, right? No submissions. That's amazing. So I think I just opened the link in the last stream. You are given a string that represents the postfix form of a valid mathematical expression. Again, postfix is, I'm telling this to you guys every time. I swear to God, there's only one guy in my chat each time. And I'm gonna go and ask him today if he remembers. Oh, and he's not here today. It's just me. That's completely fine. Right, so operator it says a plus b. This is infix. And you need to convert postfix to infix. Postfix is basically you take this operator and you bring it right over here, right? Remove that. This becomes a plus a b. Nice. I want this to be. Is this not? Can I get a b? That's, no, I cannot. Not cool. No, not working. Will it work if I do this? No, it won't work. But it will work if I do this. Right. So it becomes plus ab. You're given a string that represents the postfix form of a valid mathematical expression converted to its infix form. Right. Um, A B star C plus. So this is a postfix form. Basically, I think we both know the approach at this point, right? You add everything to a stack, you find an operator, and then but this is a postfix, right? So I think I'll have to move from right to left. No, 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 left to right is fine. Right, add everything to a fucking stack. The moment you find an operator, pop. That's the right part. Put the operator in the middle. Left part is another pop. So let's just take this example and then we're gonna add it to a stack. Right, take a look at this. We've got a stack right here. And right, go from left to right every time. This is such a bad. Can I get oh, bro, so many pixels, I don't like that. Anyways, so we're moving, right? We get A and then we get B and then we get star. So pop this out. We pop this out. This is the right part of the equation. Get this star. We pop this out. This is the left part of the equation. Turn this into such a bad A. Turn this into a bracket wala thing and you take this, put it inside the stack. You pop these from the stack. Right, A star B and then C plus. I think this is exactly what I need to do. So I'm gonna create a stack of string st for int I equal to 0. I loops from 0 to the length of the string -1. Add to just a second. I gotta talk to someone about the internship. Uh, right. So this loops from the 0 to the length of the string -1. And for if I'm going to create a set and I'm going to create a character that's going to be xi and then create a set of no character called operators and then it's going to be equal to well this right and then there's a plus and then there's a minus and then there's a star and then there's a divide, right? That checks if the character is a part of the operators. If it is, you got to do something else. You got to just push it in. Convert it into a string first. So it's gonna be this, and it's an operator. Well, s1 equal to st dot top, and I'm gonna do the same. Oh god, I'm gonna do the same for string s2. Add a pop. Pop it again, and then we're gonna push back this into the stack. So it's with brackets, right? So s2 is gonna be right here, and then an operator itself, and then s1, and then this. I ain't gonna feel like you. Yeah, I ain't gonna feel like right, and then that should return me the top of the stack. And that should be my answer. Holy fuck. Okay, nothing to worry about. Just my mic setup dwindling apart slowly. Right, got it. Set again. Let's hope it doesn't fall away. 'Cause I'm only one call away. I'll be here to save the day. Yes, let's go. So we solved one question, which I don't think I need to revise over again. This concept is so ingrained inside me. Another question, convert infix to prefix. Oh, this is gonna be nice because these questions are more harder because you need to keep track of the priorities and shit. Right. Can I get the practice part of it? No, I cannot. Oh, I hate you. I have to do it on. Oh, I don't want to do it on this platform, bro. Just lets me run code 3 times. This is fucked. Don't run directly to the solution. Try it out first. Well, I don't want to try it out. I want to. It's not even. Mm, Complex parsing. They require complex algorithms to parse, to properly evaluate them, dealing with operator precedence and parentheses, ambiguity. Infix notation can be ambiguous. Multiple operators, same level. Complexity, converting infix to a form suitable for evaluation, postfix or prefix. Someone's at the door and someone's in the chat, and I'm gonna say hi to both of them, but I'll be back to chat in just a second. Right, and I'm back. I'm here. You don't need to stream alone. That's so awesome of you, friend. Right. Um, I can't find it on. What's the problem of the day? Austin, Google, IBM, and 7 others. Mm. You and your friends in Jax play a game of coins. In Jax places n number of coins in a straight line. The rule of the game is as follows. Let's try and do this. This looks like a good question. It's a long question. These sort of questions really test you because lot of words get you jumbled around inside your head. So me and my friend, that's me, that's my friend. I wish there was a way you could look at this. It would be so nice, isn't it? But I can just open this up in another tab along with. Why have I fucking solved this already? What? This is solved already for me? Man. Ah, this website is so fucked. They already solved the question for me. Anyways, so me and my friend are playing a game, and I can open Excalibur in this tab, and I can put them side by side, and you guys can watch me draw. That's me. That's me. Right. And that's my friend. Right. Just lists the n places the n number of coins in a straight line. Places n number of coins in a straight line. I need to make these gold coins and I need to increase the stroke width. So it's 1. And then I'm gonna that's no straight line. Right. That's straighter. As straight as me. Um, each coin has a value associated with it. The rules of the game are as follows. So each coin has a value associated with it. It's a two-player game played against an opponent with alternating turns. Right, so alternating turns. At each turn, the player picks either the first or the last coin from the line and permanently removes it. I have seen this question somewhere. The value associated with the coin picked by the player adds up. Value associated with the coin picked by the player adds up to the total amount the player wins. Ninjax is a good friend of yours and asks you to start first. Your task is to find the maximum amount you can definitely win at the end of this game. And is always even. Ninjax is as smart as you, so he will play as to maximize the amount he wins. Right. Mm-hmm. Can I get rid of this, please? I don't care what you sell. Vector and coins int n. I don't care what you sell. And I was talking to dad and he was telling me about one of his ex-student. He has a job in Opta. He has the same company which has Opta Supercomputer and predicts every sporting event. I had no idea Opta is a company, honestly. No idea it was a company. That's crazy. Supercomputers and shit. He's also done masters in EcoYZ in fucking tech, like prediction shit, stats and stuff. But the values associated with 4 coins be this 9, 5, 21, 7. That's initially you pick 9 and Jax picks 7. Then you pick 21 and Jax picks 5. So you win a total amount of 9 plus 21. In case you would have picked up 7 initially. and then Jax would have picked up 21 as he plays optimally. Then you would pick 9 and Jax would choose 5. So you win a total amount of 7 plus 9, that is 16. It's not the maximum you can obtain. Right, example 2. So just doing this greedily, I pick up 20, he picks up 50. I pick up 10 and he wins. But if I pick up 10, he picks 20 and I get 50. Opta Analytics is the company name, so yeah, analysis and shit. Got it. So you win a total amount of 10 plus 10. That's the maximum amount you can win is 60. So I see a pattern here. What you want to do is you don't want to optimize for just these two ends of the coin. You want to optimize for this one too, right? So in the whole thing, you optimize for two coins. So you look at left, left minus one, right, minus one, and right, and you see the maximum. If this is the maximum, then well, so these can be four cases. So let's say this is 1, 2, 3, 4. Let's just do this. This is the maximum, this is the second maximum, third maximum, fourth maximum. I think I just need to solve for this case for 4 and I'll be done. All right, what's the constraint? Let's look at the constraints of the problem. So the value of n, the size of n coins, right? N lies between 2 and 10. Right, so from the left hand it will be these two, and from the right hand it will be these two. That's fine. So in this case, you pick up this. You pick this up. And then he picks this. And then you pick this, and he picks this. So you pick up this, and he gets this, and you get this. What he picks first, you get fourth. He picks second, you get third. You pick first, he picks first, you get second. He picks fourth, and you get third. Okay. So in this case, you just want the highest number, right? So you just pick the left one. What's another case that can be possible? Right, let's say this. In this case, you should pick up. But I think you need to calculate a lot, right? Because what if 2 plus 3 is greater than 1? Well, then you for sure want 1, right? Like you want 2. Hmm. You better write on code yourself. You better write on code yourself. 1 plus 2 is always going to be greater than 3 plus 4. I know that for a fact. 2 plus 3 is always going to be greater than 1 plus 4. I don't know that fact. I don't know that fact either. All I know is, you know what, where I've seen this question. So there was this coding competition in my college. They were asking DSA question, and this is exactly the question that showed up. I wasn't able to solve it back then. I wanna fucking solve it today. Right. What are you supposed to do? But if they don't cover you still. I have a solution right here. I'm gonna copy it or post it on my VS Code. Not post it, I'm gonna paste it. Let's comment it out entirely. I don't want to break my application. Ugh, right. And then we're gonna reset the code. Bro. Time complexity 1 square, space complexity 1 square, where n is the number of coins. I don't give a fuck. I don't give a fuck. Huh? Optimal strategy of game choice. Hmm. If I didn't write play on covered used to. If I didn't write play on covered used to. Love me. And I don't know. If I didn't write play on covered used to. I still can't think of a fucking solution. Only the greedy approach that comes to my mind, but that fails right here. Second example, you take 10, 20, he takes 10, he takes 50. You can't let that happen. If I didn't write play on covered used to. Man. Right, I'm gonna think till 15 and we'll see if I can think of something. Um, one plus three, one plus one. Well, there's one thing I can do. I can start by optimizing for the highest number, right? Like optimize. So I see 50, I optimize for 50. So my I want this or this to be taken. Alright, then I'll need to choose this. Let's do that to another one. 95217. Right, you look at this. Say, I want these moves, so you choose this. That's one thing you can do. What if it's 5217? Well, then you can't win. I don't have to win, I want to find the maximum I can take. Man. Alright, I'm ready to look at the solution. So there's a DPO of n vector in n0. It represents the maximum amount you can win for subarray I को j. Ensure values initialized as 0. n trend and 0. Is equal to I plus n minus 1. Component. It's a question of dynamic programming. Can you get a good? Holy shit, 10 years ago. 10 years ago. Risk strategy guide. Man, I feel like this is the video that's gonna
In this video, we will
explain
discuss the
shit to me.
problem optimal strategy for a game. This problem previously has
You
been asked in some
they
of the
don't cover what you saw.
exam, and it's a very easy and good.
So that just happened.
Hi everyone, in this video we will discuss the problem optimal strategy for a game. This problem previously has been asked in some of the product companies as well, and it's a very easy and good problem. So let's see what the problem says, and then we will see which approach will help us to solve this particular problem. Now in this problem, we will be given an array which will be of n size. Then the elements of the array represent n coin of value v1, v2, v3 up till vn. So basically, if suppose that there is any ith element, so it will represent the ith element will represent the number of coins. Okay. Then after that, you are playing a game based on opponent, and this game is going in an alternate fashion. So basically, there's a game that is going on in this array, and the players are changing the turn one after the other. Because the problem says that the game is going in alternate manner. So basically, the first player will play, then after that, the second player will take a chance. Then after that, first player will again take a chance, then second player, then first player, then second player. So alternatively, they will keep on changing their chances, and then after that, in each turn, there is a way in which they can choose an element. Okay. So in each turn, the player will select either the first element or the last element. Okay. So whatever is the current situation of the array, the player is going to do what a player can either choose the first or the last coin, first or the last element, you can say, from that row, and he can remove that element from the row permanently, and he will receive that value. So basically, suppose there's an array, and player one will start. So suppose that the player one starts, so he will have an option. He will option B. So suppose that if this is the array, right? So if the player one will start, then you will have the elements from 0 to x till n minus 1 index. So let's assume that the player one takes the 0th element. Okay. Suppose that the player one takes the element which is present at 0th index. Now when the player one will take this particular element, so this much value will get updated for the player one, and then after that, what is going to happen is this particular element will be assumed that it is not present in the array. So now after this, the remaining part, the remaining array will be from the index 1 till n minus 1 you can say. Okay. Or what might happen is, if you will try to generalize this, so suppose that you have the array, suppose that you have been given the array. So what will happen in general is, suppose we have this particular array. So if we assume that we are currently at the ith index, like I is the starting index currently, and j is the ending index. So if I take the element I, okay, if the current player takes the ith element, then from next time you will have the which element you can take from there. You will have the range from I plus 1 to j. Okay, so next time the ith element will not be considered because you have removed it. So from the next time you can either take the I plus 1 or the j element, and the range of the array will be from I plus 1 to j. Or what you can do is, if suppose that you have this array from I index till j index, if you take the jth element, suppose, then what will happen is, if you take the jth element, then you consider then you will add the jth element's value for that particular player, and then after that what you are going to do is, you are going to say that now the array will be from I to j minus 1, and the next player will pick either the ith element or the j minus 1 element if it is valid. Okay, so this is how it is going to be. Basically, either a player can take an element from the whatever is the situation of the array, either a player can take from the starting or from the ending, right? And once you are done with that, then you will remove that element, and that much value will get added to that particular player. Now, what is your task? So basically, you need to determine the maximum possible amount of money you can win if you go first. So suppose that player one will start the game, okay, and you are considered as the player one. What you have to do is, you have to determine that what is the maximum possible amount of money that you can win if you will go first. And both the players are playing optimally. What does this mean? So when they are saying that both the players are playing optimally, this basically indicates that both the players are going to play for their win. Okay. Now the thing is that whenever there is a player who is going to pick any element, right? So either he can pick from the ending or from the starting, right? And then this will keep on following. So one thing that is very clear with this particular problem is, there will be many possible ways, right? Many possible ways in which the players can pick the element. Okay, so suppose that if you're the first player and you're going to start, then either you can pick the first element or the last element, and then after that the second player will play, then your turn will come again. So there will be many possibilities. There will be many possible ways.
I feel like there's a, I don't know why I just got it, but there's a recursive solution to the problem because there's one possibility and there's another possibility. Man, why don't I think of this on my own? I needed to start the video and then I got it. It's obviously not gonna pass though, because then I think it's gonna take a lot of time.
So whenever there's a question, then you have to explore all possible ways, or basically you can say all possibilities. Which concept comes to our mind? The concept of dynamic programming comes to our mind, right? So this problem is nothing but concept will be dynamic programming, or you can say regression. Basically, when you're applying regression, since there will be a lot of overlapping problems, if a particular problem is already calculated, then you would not like to calculate it again. So that is why this problem will come in this category of DB. And since you want to explore what possible ways, so you use regression, and for the overlapping problems, you can apply DB into it. Okay, I hope that this particular part is clear. Now, what all things will be there? So suppose that if you will write a solve function, so whenever you will write a
I swear to God, if he writes a recursive code to this, I'm gonna fucking kill myself.
so in that solve function, you will always pass the ith index and the jth index. Ith index will indicate the current first element of the array, and jth index will indicate that whatever is the string of the array, what is the last element of that current array. Okay, you can access. And then after that, you will pass several other parameters, and that function will try to return you the maximum value that the player one will get if the player one is starting. Okay, and one more thing is there that why we will write the solve function. So suppose if we write the solve function, so in that function, we know that we will be passing the ith index, we will be passing the jth index. Ith index will indicate the current starting, jth index will indicate the current ending, and then we will also pass the player. Okay, why we will pass the player? Player variable will indicate that which player is playing. Okay, I can say that for player we can take 0 and 1. If the player value is 0, so this means let's say the first player is playing, right? The starting player is playing. If the player variable is playing value is 1, this means that the second player is playing. Okay, so this parameter we will pass, and then the original array that has also been given to us, we will also pass that. Right, so these are several things that we need to keep in mind while passing, because they will be important. And initially, we will initially mark the player value as 0, because we will say that the first player is going to win, and for the first player I have taken the player value as 0. For the second player, the player value will be 1. Okay, and after this, it's currently the situation is from this ith index to this jth index, right? So either you can pick this ith index or this jth index, so you will try all the possible ways. And also it will depend on which player is having a chance, right? Because suppose that if the chance is for player 1, okay, if the player value is 0, suppose if the player variable is having the value as 0, what does that indicate? Variable being 0 will indicate that the first player is playing. Whenever the first player is playing, you will try and the first player will collect maximum amount of value, right? Or maximum amount of money. But whenever the player value will be 1, whenever the player value will be 1, so you can say that in that case the second player will be playing, and whenever the second player is playing, so you will try to do what? You will try to minimize the collection of the second player. Okay, this is very important. That whenever the player value is 0, so this indicates that the first player is playing. So whenever the first player is playing, so you can either take the ith element or the jth element. Whatever he has to take out of these two, you will try to maximize this.
All players are playing optimally though, right?
You will try to do what? You will try to minimize the collection of the second player. Okay, this is very important. That whenever the player value is 0, so this indicates that the first player is playing. So whenever the first player is playing, so you can either take the ith element or the jth element. The first player will collect maximum amount of value, right? Or maximum amount of money. But whenever the player value will be 1, whenever the player value will be 1, so you can say that in that case the second player will be playing, and whenever the second player is playing, so you will try to do what? You will try to minimize the collection of the second player. Okay, this is very important. That whenever the player value is 0, so this indicates that the first player is playing. So whenever the first player is playing, so you can either take the ith element or the jth element. Whatever he has to take out of these two, you will try to maximize his choice, right? You will try to maximize the value that he will take. Okay, and whenever the player variable is having the value as 1, this means that the second player will be there. And whenever second player will be playing, you want the second player to collect lesser money, so that more amount of money is left for the first player. So that is why whenever second player's turn will be there, whenever the variable will indicate that the second player's turn is there, then you will do what? Then you will simply say that you will try to minimize the collection of the second player. That is how you can maximize the collection of the first player, basically. I hope that this part is pretty much clear to you. Now, what will happen is, as you will keep on taking the elements, so every time your I and j will keep on decreasing one by one, right? You basically the I index and the j index, as you will keep on taking, so your array size will keep on shrinking. And basically, suppose that in the starting, if the ith element was standing here and the j was here, so then they will I and j will keep on moving one by one as considering the way that you will take them. Then what will happen after that? You can say that one by one when you keep on taking the elements, so you are kind of removing them, right? So at the end of the day, there will be nothing. There will be no element. So when I and j will cross each other, whenever I will be greater than j, then you will say that you cannot make any collections, because when I and j are cross each other, so this means that the array is completely over. You have exhausted the whole array, and you cannot make any further collections, right? So these things are there that you need to keep in mind. Now, as I said, that whenever the turn will be for player is equal to 0, that is for the very first player whenever you are having a turn. So for that, you will try to maximize the collection. And whenever the second player is going to play, so you will try to minimize the collection. That is whenever the player variable value is 1. So you can get second player will play. So you will try to minimize the collection. I hope that this part is clear. Now let's try and write a little bit of code so that we can get more clarity on this. Firstly, we will write the recursive approach, and then after that, we will try to optimize our approach. That is, we will try to apply dynamic programming into it. Okay. So what we will be doing here is, first of all, we will return solve function. Let's say, so we will call a solve function where initially we will pass the index as 0, the starting index as 0, and the last index as n minus 1. Then we will pass the ARR array as well, and then initially we will say that the player value will be 0, indicating the first player is playing. Okay. After this, what we will do is we will write a function that is long solve, and in this particular function, we will have the index I, then the index j. Then after that, we will also have the array ARR, and then we will also have the int player. So if the player value is 0, this means that the first player is playing. If the player value is 1, so this means that the second player is playing in its turn. So whenever the I value will be greater than 0, so this means that you cannot make any collections. So you will return what? You will simply return 0. Okay, this is very basic. Now after this, what you will do is, if suppose that the player value is what is, if the player value is 0, so this means that the first player is playing. Okay, first player is playing. So then you will do it. If the player 1 is playing, then there are two choices, right? Let's say there is a choice 1 that you can have. The choice 1 is that you can take the ith element. If you will take the ith element, then how much value will get added? ARR I value is going to get added in your account, and then you will call the solve function. And since you have taken the ith element, so now you will have the range of the array from I plus 1 till j, and you will pass the ARR array, and the player will change. So currently, if the player was 0, so you want to pass the player as what? You want next time you want to pass the player as 1, basically, right? I hope that this makes sense. And similarly, the choice 2 can be what? That if you are having the array I from the range I to j, so either you can take the ith element or you can take the j element. So suppose that you pick the j element, then you will do what? Then you will call the solve function, and you will say that now the next range of the array will be from I to j minus 1. Why j minus 1? Because if you have taken the j element, so you have to remove it from the array indirectly, and then you pass. And out of these two, which choice are you going to return? You are going to return the maximum of the two choices. Why you will return the maximum of the two choices? Simply because whenever the first player is playing, so you want to maximize the collection of the first player, right? Otherwise, suppose that the second player would have been playing. Okay, if the second player was playing, then what you will do? Then you will say that the choice 1 can be that the player takes the ith element, and then you can call the solve function for what? I plus 1, j, AR, and then after the player 1 comes in, after the second player has played, then you will pass the parameter as 0, indicating that the next time the chance will be for the first player, because they are taking turns for the negative. Another choice 2 can be what? That you can take the jth element, okay, and then you can call the source function for what? For I, comma j minus 1, because if the jth element is taken, then you pass the index as j minus 1, then you pass the array, and you will pass this parameter as 0. Why you will pass this parameter as 0? Because if the second layer is charged, so next time the chance will be for the first player. So you will pass the value as 0, indicating that the first player's chance will be next time. Okay, and out of these two choices, you will return the minimum, because if the second player is playing, so you would like to collect the minimum amount of money. So that is why you will take the minimum, so that more money is left for the player one to collect. Okay, if the second player collects lesser money, so your chances of collecting more money gets higher. Okay, let's try and combine this code to check if it is working fine on the sample test cases that we have or not. So yes, I have made some basic error here. So it says that in solve function, I have not passed this array properly. So let me check what is the issue. Yeah, so I have not written long ready. Now the spelling is correct. So let's check what is the situation now. Okay, so I am not getting the optimal answer for some reason. So whenever, let's say whenever the player one was playing, so let me just check if I have made any mistake here. So what I've done is I have passed the index as 0, then n minus 1, then I have passed the error, and I have passed the player
They're not both playing optimally, are they now?
value as 0. Okay, then if the I value is greater than j, then I'm returning this thing. Okay, otherwise, what I am doing is I am passing the player value. If the player value suppose is 0, so this means that the first player is having a chance. So if the first player is having a chance, then what I will do is I will take the choice for this, I will take the ith element, and if I do that, then I will call the solve function from I plus 1, comma j. Okay, and I will pass the array, and next time the chance will be for the second player. So I will be passing the parameter as 1. Otherwise, suppose that if I take the j element, then I'll call the solve function I comma j minus 1. Okay, and then I'll pass the array, and then I'll pass this parameter as 1. And
If we are returning the minimum value from the player 2, which means he's playing optimally, so when you go to, no, I don't actually get it. If you are returning the minimum value from player 2, which means he's playing optimally to get the maximum value. But thereafter, we are returning the minimum value. Like this. Step there to in my main cover, so this call will return me so C1 and C2. It's gonna return maximum of C1 and C2. Why would you want the minimum if he's playing optimally? Let's ask ChatGPT. Are you familiar with the optimal something? Can't just greedily pick the max coin because your opponent also plays smartly and will bluff your future moves. So you must use recursion with memorization or DP table and consider all choices. Maximum value you can collect from ally. It was a recursive question. How could I not? It was a fucking recursive question. You either pick the right or you pick the left. I I have no idea why I could not see this. I am so disappointed in myself, honestly. Right, so I'm gonna leave you with either ally this or this depending on the most interesting. min because explain the solution to me. Strategy will work twice the first one. Your goal find the maximum you can collect if you play first. Inside you consider the choice to affects what option the opponent gets tomorrow, and your opponent will always try to block your best options. Right. At each step, you can either pick either the first one or the last one. Once you pick, your opponent gets their turn, and your opponent will make the moves that gives you the worst future. So for every choice you make, your opponent chooses a move that gives you the minimum possible gain after that. This is where we use. Okay. So every choice I make, I want the maximum. Every choice my opponent makes, he wants me to get the minimum. Max add I plus min. And minimize maximum damage the opponent can do. Similar to few turns by hand. You pick 20, opponent picks 5, you live for 4, 6. Then 4, your total 20 plus 6. You pick 5, they pick 4, your total 6. This is the kind of reasoning similar to using dynamic programming. How the fuck is this dynamic? What is dynamic programming? I, it's recurrence relation. Yeah, I watched a video on this. It was basically just recursion. Dynamic programming is recursion. It's actually recurrence relations and kind of mathematical, but it's at its core, well, some sort of recursion. Every ij, you choose either I or j. The opponent picks next and leaves you with the worst remaining throw you with the best. Recursion just memorization. Okay, so what this does exactly is right. So we start if whatever this is just the base case. If it's my turn, then I check if I what happens when I do left, and check what happens if I do right. I got two possibilities. I want the maximum of the two, and then it's my opponent's turn. Right, he checks what happens when this guy chooses right, what happens when this guy chooses left, and he returns the minimum of the two.
Return the maximum. Why we will return the maximum? Because we want to maximize the potential for the first like for the first player. Otherwise, if suppose the second player is playing, so there can be two choices, like what you can do. So suppose that if the player two is playing. So if the player two is playing, so the thing is that whenever the player two is playing, whatever he will be correcting, you don't need to add it in your answer, because the addition, if you whatever player two is correcting, you don't need to add that to the correction of the player one. So that is why we don't need to add this particular value.
Yeah, exactly. That works. That works. That works. But you're not adding to anything. Fucking cunt. Then yes. Now this makes a lot of sense.
So the thing is that whenever player two will be playing, so either he will pick the ith element or he will pick the jth element. Based on that, you will make the first, but you will not add the values. Why you will not add the values? Because ultimately I have to just return the amount collected by the first player. So whatever indexes the player two is collecting, I don't have to add its value. Otherwise, my answer would increase because I only have to return the collection made by the first player. So that's why whenever player two is collecting, so I will not add it in my answer. Okay. So yeah, this is the thing. Now let's try and compile this to check if it is working fine or not. Okay, now we are getting the same answer. Earlier you can see that we were getting more answer. Why we were getting a greater answer than expected? Because I was adding the value connected to the second player. So okay, let's submit this code. It will give us a time limit exceeded. Why will it give us time limit exceeded? Because there are a lot of overlapping subproblems here. So you can see that we are getting T layer. So basically for this we need to declare 2D declare array because two parameters are changing here constantly. I index and j index. So what I can do here is I can simply declare a vector of vector in sorry, let's say long, and then after this let's name it as v or let's name it as vp. And after that what we will do is we will declare n comma vector, then long, and then n comma minus 1. Okay, so initially we will update our dp array as minus 1. Then after this what you will do is we will also pass the vector of vector long. Okay, here the dp array will be passed. So let's say ampersand dp, and then we will check that if the dp of ij is not equal to minus 1. So this means that if that state is already calculated, so we'll not calculate it again and we'll simply return dp of ij. Otherwise what we will do is we'll calculate it, store it, and then return it. So we'll mark dp of ij as maximum of the choice 1, choice 2 if the first player is playing, and then we'll store that maximum and then return it. Okay.
db of I.
And otherwise, what we do is we'll give you 5j is equal to minimum, right? So if suppose that the second string, then in that case also we will store the minimum of that. Okay. Then after this, we need to pass the DPRA in the parameters. So let's pass this DPRA in the parameters of all the source function calls that I am taking. So here, it's maximum of the choice one choice. So if the first player is string, and then we'll store that maximum and then return it. Okay. And otherwise, what we do is we'll give you 5j is equal to minimum, right? So if suppose that the second player is string, then in that case also we will store the minimum of that. Okay. Then after this, we need to pass the DPRA in the parameters. So let's pass this DPRA in the parameters of the source function calls that I am taking. So here also I pass it, and then here also.
Why are you returning? What?
Pass it. Okay. Next one, compile it.
Return it
It's
separately.
mixed to check if it is accepted. It should get accepted now.
I don't
Take
know.
it easy and once able to pass all the test cases that are there. And talking about the time and the space complexity of this code. So what will the space complexity first of all? Since I am doing what? I am declaring a 2D array of n cross n size because I'm storing two parameters that is I and j. So I'm having degree of ij. So that is why the space complexity for this approach will be order of n square. What is going to be the time complexity for an approach? Time complexity will be order of n square because in the worst case there will be n square different states. Because if you will see, if you have I and j as the parameters that are changing, so I can maximum have 10 different values and j can have maximum 10 different values. So total of different states will be n square. So I hope that you are
Um,
in 2025, if your resume doesn't
wait a fucking second. 21 hours ago.
first of all, I hope you all give it a try.
Wait a fucking second. I have seen this guy.
आप कभी भी डायरेक्ट वीडियो सॉल्यूशन पे किसी क्वेश्चन के आइए पहले खुद को समय दीजिए जब समझ में आ जाए तो क्लिक जाइए वहां से थोड़ा बहुत डिस्कशन देखिए या फिर आप टूल देखिए पहले ना पहले आपको टिप्स मिले और एक्चुअली में सॉल्यूशन आप खुद ही सॉल्व
Bro. Bro. Wasn't this guy was teaching mathematics at Aman Datharwal's channel when I was in 12th grade. Holy shit. She pays that much? I had no idea. Because that guy was paying a lot, I know that. Just right, am I? Yes, once every 5 minutes. I mean, minimum. I'm sorry, Dev, I have no idea what you're saying. I've got two concurrent viewers somehow. Who's the other person watching? Do I have to chat to show my presence? Oh, it's freshest. Holy hell. I've got people watching me now. I've got expectations and I've got a burden on these shoulders now. Read the chat, fresh this year. Yeah, that's what I did. That's just what I did. It's crazy. These questions are very, very, very important as we can see. I just spend my time banging my head against a question I could have solved and I did not solve. I've been practicing recursion for the past few days and I just could not figure out it was a part of recursion. Let's see. Monotonic stacks and queues. Monotonic is strictly increasing or strictly decreasing order. Let's see. Next data element 1. The next data element of some element x in an array is the first data element that is to the right of x in the same array. And means the array is sorted in ascending order, but it's got duplicate elements. Uh-huh. Next data element of some element x in an array is the first data element that is to the right of x in the same array. Yeah, I read that right. You are given two distinct zero-indexed integer arrays. Distinct zero-indexed integer arrays, nums1 and num2. Nums1 is a subset of nums2. What? It's distinct. Okay, you are given two distinct zero-indexed integer arrays, num1 and num2, where nums1 is a subset of nums2. For each 0 is less than or equal to I is less than nums1 dot length, and the index j such that nums1 I is equal to nums2 j. For each I from 0 to nums1.length. Nums1 is a subset. This is kind of a lot of information to digest for me without writing, so I'm gonna do that. Right. X, y. Y is greater than X. Necessarily. Right. Nums1, nums2. Nums1 is a subset of nums2. I from 0 to nums1 length. For each this, find the index j such that nums1 I equal to nums2 j. Nums1 I equal to nums2 j and determine the next greater element of nums2 j. Why the fuck? And determine the next greater. A lot of fluff. Next greater element of nums2 j in nums2. Gonna be nums2 j plus 1. If there is no greater next element, the answer of this query is -1. Return an answer array answer of length nums1 dot length such that answer I is the next data element as described above. Let's look at the examples. Nums1 equal to 412, nums2 equal to 1342. All right, so this definition is just for the question itself. Next data element means the element next to x that is greater. Fuck you, bro. Two distinct zero indexed integer arrays. Distinct means they've got distinct numbers. Nums1 is subset on nums2. Right. Next data element of nums2 j and nums2. So nums1 is 412, nums2 is 1342. Output is -1, 3, -1. Next data element for each value of nums1 is as follows. For 4, it's gonna be -1. -4 is underlined in nums2. There is no next data element, so the answer is -1. -1 is underlined in nums2, so next data element is 3. -1 is underlined in nums3, there is no next data element, so the answer is 1. Just by looking at this question, I've got a solution that is n square time complexity at least. But I'm pretty sure this can be solved in less than that. And somehow we need to use stacks and queues for this. That's fucked, isn't it? Mm-hmm. For int I equal to 0, I is less than nums1 dot length size I plus plus. Right. Num equal to nums1 I, and then you find like in pre-process. Next greater element. So I go through this array. 1, point I equal to 0. I is less than nums2 dot size. I'm just gonna create a new array. I plus plus and num equal to nums2 I for int j equal to I plus 1, while j is less than nums2 dot size. We're gonna do j plus plus and then oh fucking keyboard, if nums to j is greater than num, create a new vector int pre-computed. The size of it's gonna be nums2 dot size. Nums2 dot size, and you initialize it with -1. So all of them are going to be -1. And if nums2 j is greater than num, well then A, you break out of this loop, and B, you set pre-computed I equal to j. So we got a pre-computed index, and then it's called distinct elements, right? I'm already doing that, so I'm just gonna create a hash map too while we're at it. We're already traversing the second array once, so we can at least create a map that lets us access the index quickly. Int indexes, and then you just do indexes I equal to num equal to I. That's better. Num I I need to create an index, or I can just, no, I won't change the, because it's a pass by reference, or else I would have just changed the input array. So you create a vector in ans, and then you do ans dot push back, pre-computed. Now you want the index. This is of num, and then you return ans. And all of them are wrong. Oh, why am I getting 3? Maybe I'm told you so. Wait. So it's gotta be It doesn't want the index, it wants the actual number. This should do the trick then. You're in a vibe, they don't code you, so. What the fuck? I got 100% solution. What? N squared due to nested loop. I am. The optimal approach is creating a monotonic stack. Right. How do you create a fucking monotonic stack?
With ROI measurement made easy, I can hire the right candidates faster with LinkedIn.
Mhm. Well, next zero top equal to num. What? What? I don't get it.
So let's continue with the Stack and Cube playlist. Before starting off, hey, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is next greater element. So from this problem onwards, we'll be starting off with monotonic stack. So what is monotonic stack? Till now, I've been using stack to store elements. At the moment, we use stack to store elements in a specific order. In a specific order, that is when we call it as a monotonic stack. So maybe I can store elements in an increasing order in the stack, or maybe in a decreasing order, or maybe in some other order. So whenever we are following a specific order, that's when we call it as a monotonic stack. Got it? So this problem is next greater element, or commonly known as NGE. So what is the problem statement? It's stating that we are given an array for every element. For every element in the array, you have to tell me which one is the next greater element, as the name is telling you what it is all about. So you basically stand at 6, and then you look at the next elements. Is 0 greater than 6? No, it is not. Is 8 greater than 6? Yes, it is. The first element that is greater than the element. So you see that 8 is the NGE of 6. So what I can do is I can write 8. If you stand at 0 and if you look at the right, if you look at the right, 8 is the next great element. So again, I can write 8. If I stand at 8 and I look at the right, I have a 3 array is what you will have to return. Straightforward, isn't it? What is the first approach that comes to my mind? For every element, go to the right and find it. So I iterate on the array. I can.
Right, I
Once
do
you're done with
that.
this, give an input. Don't do it, okay? It's not a good practice. What about the time complexity? Turning the NGE array. Done, understood. Again, now you cannot use this NGE array and maybe you can modify the given array itself. But in an interview, it is not encouraged to modify the given input. Don't do it, okay? It's not a good practice. What about the time complexity? Can I say I'm running a couple of loops? Yes, I am. So big of n square near about big of n square. What about the space complexity? Can I say that the amount of space that I'm taking is around big of n? Again, this space is not used in order to solve the problem. Rather, it is used to return the answer. So it is something that you cannot avoid. At this moment, the interviewer will not be happy with the big of n square. They'll ask you to optimize. So we need to optimize big of n square. That clearly gives us an indication that we're looking something around big of n or big of 2 and big of 3n or n log n, right? Fine. So imagine you're standing at this element 3. I'm asking you, what is the NGE of 3? And in order to know the next greater element of 3, you will look towards the right. So you should be knowing the right elements. You should be knowing the right elements beforehand. But the generic way of traversal is starting from the left. You start from here, then you go here, then you go here. So there is no way that when you reach 3, you would be knowing what are the elements of the right. There is no way when you reach 3, you'll be knowing what are the elements of the right. So will it not be better if you traverse from the back? If you traverse from the back and you reach 3, at that moment, you'll be knowing what are the elements of the right, and that is what you need. first optimization or first thought process that I can think of is maybe I'll start from the back. So that at any particular index, I will be knowing what are the elements on the right. And then I can think of a solution. Then I can think of a solution. Okay, now I know where to start from. That is a back traversal. So what I will do is I'll be taking a stack, and this stack will be storing elements in a specific order. Why you'll understand as I explain. The first element is 6. So what you do is you look in the stack and you don't have anything. If you do not have anything, that means there are no right elements. So what you can do is you can simply say -1 to it. You can simply say -1 to it. Got it? What after that? After that, you take the element. There's a 6. So you can say that that can be my next great element because 6 is greater than 4. So you say, okay, I have my next great element. You take 4 and you put it into the stack. After that, you move back. Now you have something as 2. Again, you look, put it into the stack and you move back. This time you're at 1 and you look into the stack and the topmost element is 2. So you say that, okay, this is my next great element. I'll take 1 and put it back and I'll move across 3. I'll move across 3. Now this is something we need to understand. What is stack storing as of now? It's storing something of a length, like a 6 size. Just imagine light poles. Light poles of a length 6. After that, it is storing something.
I got an inkling of this specific algorithm in my head, but I just let it go for some reason. I don't know why. I just let it go. I need to stop doing that. I need to explore every possibility.
Of a length 4. After that, something of a length 2. And after that, something of a length 1. Suddenly, you are at 3. Suddenly, you are at 3. Which is typically, you can say somewhere around this. Correct? Tell me one thing. For this 3, which will be your next great element? It will be 4. For that, you'll have to take them out. And you might say, if I take them out for the future elements, I will lose out on some of the right elements. No, you'll not lose. Let me explain you why. Imagine I come up with something like 1 over here. After 3, just imagine. After 3, there's an element of length 1.
I got it.
Tell me one thing. Even if you lose out on 1 and 2 in order to get 4, because in order to get 4, you'll have to take out 1. You'll have to take out 1. So that's gone. Just imagine this is gone. For this 1, if this 3 is your answer, will 1 and 2 contribute to your answer? The answer is no. It will never contribute because for an element like 1, if 3 is the answer, 1 and 2 can never contribute because this is a light pole which sees this, and beyond this, it can never see this. Beyond this, it can only see a larger element. Beyond this, it can only see a larger element, and beyond this, a larger element. So will it not be sensible to store the elements in this decreasing order, which is like 6, 4, 2, 1. And now when 3 came up, you don't need to store 1 and 2. You don't need to store 1 and 2 because if 3 is the answer of someone, 1 and 2 can never be. 1 and 2 can never be. Got it? So what I do is, I'm at 3, right? I'm at 3. I'm saying 1 can never be my answer. Now when you move to 2, top of the stack, again you take 1 and put it back, and you move back. This time when you're at 3, can 1 be your answer? No. Can 2 be your answer? No. So you take both of them out. You take all the elements with. When you are at 5, can 3 be your answer? No. Can 5 be your answer? No. You're looking for greater. So I end up deleting both of them. Can 6 be your answer? Yes. So right. After this, I'll insert 5 and I'll move back. When I am at 5, I look onto the stack. No, no. So both of them can go off. Both of them can go off, and the stack will be empty. And the stack
Use control.
is empty. You say that the answer is -1, and you put back 12. And now you go back. 4, top of the stack is 12. That can be your answer. Put back 4, and then go off. You're done. And this is your next greater element. This is your answer. Yes. So what did I do over here? I did use a monotonic stack. Why? Because I was storing the elements in a specific order, and that specific order was the decreasing order. Yes, the decreasing order. If you carefully notice, I stored 6, which is typically, let's say, here, and I stored 5, let's say typically here, and I stored 2, let's say typically 2 is here, and I stored 1, which is typical. Okay, perfect. So time to write up the rows. I removed 2 and 1 so that the decreasing order is still maintained. So that the decreasing order is still maintained because I'm decreasing it. Got it? So I hope you got next, like you got the concept of next great element. The intuition comes from the light poles. If you're a human being and you're looking on the rightward direction, it's obvious that you'll only see increasing stuff. Nothing in between that. You'll just see the increasing curve. Correct? So the intuition comes from there. Perfect. It's time to write down the pseudocode. So we will be returning a list or a vector according to the language that you're writing in. So we're returning a list of going. And there's something that I'll only remove the elements at the worst possible. The space complexity to my answers. That will be the time complexity and the space complexity. So wrap up this video. Let's make some of the video in my
Don't forget your code. Off on the light, off on the storm.
global machine learning market is expected to touch $31.36
Really?
billion by 2028. Machine learning has reached new heights everywhere, with businesses implementing ML algorithms to enhance their capabilities. So, what is
Like I give a fuck. Like I give a single goddamn fuck. Well. That is what I should have done in the first place. I should have for int I equal to nums2 dot size. I always size I is greater than or equal to 0. And I minus. And you're gonna create a stack. Create a stack that stores integers. Call it st if st.empty. or this is such a weird place for the pipe symbol to be in my keyboard. Nums2 I, right, or num is greater than st.top. So if it's empty, or if num is greater than stack.top, well then you no less than stack.top. Right, because okay, let's start here. 2, 4. If you get 4, I mean it's not empty and num is greater than stack.top, where num is greater than stack.top st. Stack is not empty. It's coming false. And num is in st.top while you know st.top. And then if dot empty you wanna push num, and then you want next of I to -1 because there's no element greater than it, right? And else if it's not empty, well then you still next I is equal to st.top. Regardless of anything, you're just gonna push it inside stack, right? Right. And then you just push num. Isn't that simple? Right, now you create a vector int of ns for int I equal to 0, I is less than nums 1 dot size, I plus plus ans dot push back. Well, I still need to access the nums 1, don't I? I do. I'll create an array called indexes and then just take some one I map and for indexes, and it's gonna take n indexes null equal to I. Is that it? My bad. Next. That's weird. So I starts from none to dot size. Okay, it should be -1. This is dumb on my end. It's a runtime compilation error. This gives me -100, which it should not. Next. Right, okay, let's do a dry run for this. Really don't feel like it. Really don't feel like it. I want to push this to ChatGPT. Let's do a dry run for it. So we've got a stack and we've got a map, and then we've got next. I equal to nums2.size -1. Alright, 4, that's 3. Greater than or equal to 0, I minus minus. Now equal to nums2i. Now equal to 2. And x is 2 equal to 3. If the stack is empty, right? Well then you push it into the stack and you do nothing. Right, and then you move on to the next one. So it's 2 now. Now if stack is empty, or well 4, my bad, just gonna do 4. 4 is less than st.top. Oh, well, it's not, is it? Then while st is not empty and normal doesn't st.top, you pop it. You pop 2. Now stack is empty. Stack is empty. Well, next I go to 1. So next 2. Okay. I forgot to modify the next arrow right here. Next I forgot a line right here. Ah. Yes, next 4 3 0 1 2 3. 3 is gonna be how oh I can't access next I without this. Just a second, someone's at the door. Close this. Where do you go? Right. So we've got this. Oh, this is messy. This is very messy. Can't access the stack top without this. I'm just gonna write in a condition that solves for this. So if su.empty, you do next I equal to -1, else next I equal to stack.top. I know there's a better way to implement this, but man, I don't wanna right now. Yes, that works. Yay! So I'm just gonna check in with ChatGPT. I'm gonna be like you, and I'm gonna be like pushing the current element to the stack, yada. Inconsistent updates on the next array. Pops one and needs to connect with the stack. Single stack loop, the stack only was in the small current element. Correctly. I don't really fucking care. I'm gonna do that the next time I solve this question, which has never, as I added to my Google Sheets. Well, pretty confident actually. No, use monotonic stacks. A stack, a single stack, not stacks. I close that, take that off, and then you go to next to element 2. You don't, man, kind of cooked today. Feel kind of cooked. Very interesting. Alright. Guarantee the array of size and find all elements that appear more than n by 3 times. I remember distinctly watching a lot of videos on this. So that's the Kadam's algorithm, if I'm not wrong. And to get n number, you need to create a vector of size n minus 1 and then do shenanigans with it. But if I'm late on code, you still. all elements that we have more than by 3 times. So the algorithm is pretty simple. You're just looking for a majority vote, right? So you go through here, add this, and you go to add to your array. So you add this. For element that you don't find, you subtract one from all of them. Or what sort of data structure will let me do that? I'm thinking of, I'm thinking of um, a pair of pairs. Is that okay? A pair of pairs is what I'm thinking of, which is, I don't know if that's okay. Well, I don't fucking care if that's okay. I'm gonna write my solution in anyways. Oops. Ah, num equal to nums I if if it ain't fun, they don't care what you saw. Dot first is equal to, and is the nums of I can be minus 10 is about 9. Length of nums is at least 1. Well, the length is at least 1, so I need it to be at least 2, man. Because, right, host dot first equal to nums dot, just a second. Hey, I'm back. I feel like I should be using a vector for some reason, and I want to do some simple checks. If nums dot size, or let's just say int size equal to nums dot size. If size is equal to 1, well, then you return nums. If size is equal to 2, you return nums. Basically, if it's less than equal to 2, you return nums. And then you move on to other things. Vector, pair, int votes, right? Oh God. Votes not push back nums. Okay, I want to cover. This is a pair, right? This is gonna be nums of 0, comma 1, and then do that again with nums 1, and then for int I equal to 2, I is less than nums dot size, I plus plus. Just a second. All right. For the case, let's just say I don't add this and I start with 1. Okay. Um, right. If num equal to nums I, num equal to votes 0, well then it gets a vote. Else if num equal to votes 1 dot first, well then votes 1 dot second gets a vote. I should just fucking use a map. So many checks, so many fucking checks in here. Just fucking use a map, bro. Analyze names dot size. Um, what's num plus plus if I never laid uncovered yourself. What's I need to add it. Can't they give me better array to traverse a longer one? Alright, so here are the first element. Add it. And then no, no, no. For auto uh, flag in nums, no, in votes to remove from erase key. Erase key. What's the erase key? If flag dot first is not equal to nums, if flag dot first is not equal to nums, right, and then flag dot second minus equal to 1. If flag dot second is equal to 0, then votes dot erase flag. If flag dot first is not equal to nums, I wanna die. If flag dot first is not equal, that means flag dot first is equal to nums. If flag dot first is equal to nums, then flag dot second plus equal to 1. Isn't that nice? Good for you, good for you, good for you. Except I don't want to do that in here. I'm gonna do votes num plus equal to 1. I in votes vector int minus dot push back first return ns.
Apparently, you don't go with used to it.
I'm fucking done. I'm fucking done with this. Okay, I want to add a test case. I want to add a test case. That is, holy fuck, that feels nice. I think it's gonna fail right here. Why? I'm done for the day. I have no idea why. I think my reasoning is pretty solid. I remembered the algorithm and I don't wanna fucking. What data structure are you using? You're just using numbers. I wanna kill myself. I wanna fucking kill myself. I think we're done for the day. I can't do this on stream and I've got food to eat. I'm tired. I'll see you guys tomorrow. I just finished this one question after I eat and then I'm done with DSA for the day. Right. Thank you guys for joining in. I haven't checked my chat in a while, which is something I should keep doing. Chill out, buy all the best. I know, man, this question got me bawling out here. My eyes out in the open. Right. See ya. Bye bye. Thanks for joining again. My trusty moderator, always watching my streams. I've got 10 hours of watch time now, more than 10 hours, I think.